can listen to me. Today is the 7th of April. We have our project management lecture today online because of a positive case of COVID. I was positive tested last week. That's why I couldn't fly to Germany. So we will have it online today and tomorrow, and we will see next week. So we continue by disclosing the differences between project and process management. We have seen two standard processes or two standard communication standards. One for process management called CPDNA. Some of you have sent your exercises. Some are very good, so congratulations. Some need a little bit more detail. Please hang in there. Okay, it is very difficult to have this exercise perfect by the first time. Just hang in there and try it more and more. You can send me as many times as you want. This is important because in the exam probably I will ask about this. Okay, so the process management starts with the C, then continues with P, and then D n times, and then finally goes to A. Okay, and here maybe you recall we have here a process. Okay, I painted it like this with the process owners here, and then the activities. And then the activities were sort of united together by material or information flow arrows. Okay, I don't know if you remember. If you don't remember, please make sure you visit this again. Okay, it's super important. Basically, what we do here is, let me put it in more detail here. Okay, what we do here is we take a vertical line, a horizontal line, we make a list of the process owners, whoever is touching information or material in the process. These are the process owners, PO, okay? And then we have the activities that these people are doing. After describing the activities, we paint material and information flow arrows. Okay, and basically what this is a network. Okay, if we describe the activities as with numbers, okay, let's say this is activity number 1, this is activity number 2, number 3, and number 4. Let me maybe paint this differently. Let's say this goes to here. Okay. Then the same graphic as we have up here. This is what we call the process or the value stream. The same can be described as a network. And basically what a network is intuitively is just a list of nodes and edges. Okay, so this would be 1, 2, 3, 4, and we can put numbers also. 1, 2, 3, and 4. Okay, and we can put relationships between them. So number 1 is related to, so 1 goes to 2, and 2 goes to 3, and 3 goes to 4, and 3 and 4 goes to 3, and 3 goes to 1. Okay, so this is basically our network. Okay, of course this can go to infinite. Similarly, can you follow? Is everything understandable? Should I repeat something in German? Okay, so a process can be described as a network. Okay, so are we cool? If nobody says anything, then I assume that is understood. So, but feel free to interrupt anytime, okay? Similarly, as we have already seen, and I don't mind if you ask in German, okay? So if I speak too fast or something cannot be understood, I don't mind repeating it again and again, okay? These are very important concepts and everybody needs to be following. So please do not hesitate to ask. So with the project, we said we started with this D, okay? With the do, it's a little bit different. So we start with the D, and then we continue with the C, then with the P, and then with the A. D, C, P, and A. Okay. And here, what we had is so we called it Gantt diagram or timeline. Here is a certain set of tasks that were dependent on each other. So if we put it in more detail here, it's similar. Okay, so very similar concept. We have a timeline. Here we had also this is time. Okay, so here we have a timeline, and we also have a vertical line. And instead of having process owners, what we said we were having are work packages. Okay, so Francesca, I think you might want to switch off your camera. No, no problem. It doesn't bother me, but it's your privacy. So here we have the work packages, so the activities that people are going to be performing, and then we also have the time that it takes to perform them. Okay, we were talking about this the other day. This is called, as I said, a Gantt diagram. I just make an example. Okay, 1, 2, 3, 4. It can be longer, and in the exam, it definitely will be longer. Okay, so and here we can also set certain dependencies. Okay, so whenever I am done 90% with my first activity, I can go and start with the second, and the second activity needs to be 70%, and the third activity can be 100% done, and then only then can I start with the fourth one. Okay, so this is basically 1, 2, 3, 4, A, B, C, D, whatever you want to call it. So and here this also, as you can imagine, can be described as a network in which the nodes are not the people, but the process steps, the work packages. Okay. So here we have 1, 2, 3, 4. 1, 2, 3, 4. Okay. Also a network. And we have that 1 is connected to 2. 1 is also connected to 3. 3 is connected, 2 is connected to 3, and 3 is connected to 4. Okay? So here the nodes forgot the nodes are the process owners. And the edges are material and information flow. And here the nodes are work packages. And the edges are the dependencies. Okay? So, are we on the same page? Could you follow so far? Any questions? Nobody? Ich kann auch auf Deutsch wiederholen, wenn jemand nicht folgen konnte, falls notwendig. Ich muss es nur sagen, okay? Okay, no questions, then I continue. So, as you can see, the concept of the network can be used very flexibly, and it is therefore important, and in actual terms it is very relevant for you to have tools need to be developed, need to be understood to be able to compare and quantify networks. Okay, and this is what we are going to do today. Intuitively, it is important. So the intuition tells us that this is just, as I said, an intuition. It's nothing so eine klugscheiße Hand. Okay? Damit so you can remember it well. The faster information or material flows in the network, the more effective and efficient it shall be. This sounds intuitively, sounds logical, right? The faster I get from 1 to 4, the faster I get from 1 to 4, the faster my process will go. The faster I get from 1 to 4, the faster my project will go. Does it make sense to you? Hello? Yeah? No answer? Macht das Sinn? Ja? Okay, so this is the first idea. The faster I get from A to B in the network, the better, right? First idea. Second idea, also important. And I'll make another finger here. Looks funny finger. So I don't like it. The second idea, it's also important. The more, the better people exchange information, within groups, the better this information is processed in the network. Does it make sense? So the better the communication between people is, the better the information exchange, the better people will solve problems together, and the better things will get done. Okay? So the first thing it's about information flow and getting information from A to B, and this will be measured by two KPIs, okay? KPIs, key performance indicators. The first one is the average path length, and the second is the clustering. Cluster means group in English, okay? So a cluster is a group. That's why we're talking about groups. Clustering coefficient. Okay, these are two KPIs that we are going to learn how to measure given any network. Okay, any questions so far? Okay, so let me give you a notion of how a network is defined mathematically. Okay, a network is defined in math, okay, mathematically, by a set, this is a group of nodes and a set of edges. Okay, this group of sets is called graph. Okay, a graph of the network. So we have n for the nodes, e for the edges, and the union of both, it's called a graph. It's called n united with e. Okay, a graph called G. This is how we describe networks mathematically, with graphs. So let's see an example. We will work with this example for both. Calculations, KPI calculations. I don't need to repeat it. If you have any questions, if you want me to go slower, just make your microphone on and tell me, okay? An example of a graph is given by this network. Let's put it with 6 nodes. 5 and 6, and 1, 2, 3, 4, 5 and 6, and 1 is united with 2, 2 is united with 3, 1 is united with 3, 3 with 4, 4 with 5, 3 with 5, and 4 with 6. Okay, And this would be our network. So we have a set of nodes, 1, 2, 3, 4, 5, and 6, and a set of edges, 1 to 2, 1 to 3, 2 to 3, 3 to 4, 4 to 5, 3 to 5, and 4 to 6. So we have 6 nodes and 7 edges in our network. Okay? Can you follow? Yeah. Okay. No, I hear no questions, so I continue. So now let's calculate the average path length of this network. This is the average distance between nodes in the network. Okay, so the number of steps I need to go from one node to the other. So the average path length, mathematically, APL is 1 divided by n times n minus 1. This is the total number, maximum number of relationships in the network. In the network, if the nodes don't communicate to themselves, times the sum of all paths between the nodes. Okay? All paths between the nodes. Let's calculate this with our example. Okay, this is the math. Okay, this is important to know. But it's also important to do it. Let's do it with our example. So I copy again the graph in small here. 1, 2, 3, 4, 5, and 6. And this was it. Okay, so 6 we have said is n we have said is 6, so the formula is 1 divided by 6 times 5. Okay, and then let's start calculating all the distances of all the nodes to each other. So node 1, what is the distance between node 1 and node 2? I have one step, right? If you cannot follow, let me know. So distance between node 1 and node 2 is 1 plus distance between node 1 and node 3, also one step, plus distance between node 1 and node 4. I don't take this path because this takes longer. I take the shortest, 1 and 2. Okay? Oh man. Yeah, that's what I just said. Yeah. Always the shortest. I don't know who spoke. Ferhan? Yes, so can you tell me the distance between node 1 and node 5? Yes, very good. Okay, so 1 and 2. Okay, I don't go like this. I take the shortest path. Okay, it's understood? Good. You're welcome. So what is the, just stay with me, what is the distance between 1 and 6? 3, very good. So I go 1, 2, and 3, right? Very good. So any more questions? Okay. Anybody else? Is it understood? Of course, we repeat it for the second. And we do this for all the nodes. So for the second, I mean, I try to go very step by step, but can be that I'm going too fast. So the distance between 2 and 1 is 1. Okay, so distance between 2 and 1 is, between 2 and 1 is 1. Plus the distance between 2 and 3 is also 1. Plus the distance between 2 and 4 is 2. Plus the distance between 2 and 5 is also 2. Plus the distance between 2 and 6 is 3. Plus, continue. With node number 3. Distance between 3 and 1 is 1. Plus distance between 3 and 2 is 1. Plus distance between 3 and 4 is also 1. Plus distance between 3 and 5 is also 1. Plus distance between 3 and 6 is 2. Plus, plus, Distance between 4 and 1 is 2. Distance between 4 and 2 is also 2. Between 4 and 3 is 1. Between 4 and 5 is 1. In between 4 and 6 is also 1. Continue with number 5. Distance between 5 and 1 is 2. 5 and 2 is also 2. 5 and 3 is 1. 5 and 4 is 1, and 5 and 6 is 2. Okay? And this, doing this is just easy road. Oh, I need to do the number 6 also, sorry. Number 6, don't forget. Ja, gerne. Weil es keine Verbindung gibt zwischen 5 und 6. This gets so, okay? Yeah. So for 6, the distance is between 6 and 1 is 3, plus the distance between 6 and 2 is 3 also, plus the distance between 6 and 3 is 2. Distance between 6 and 4 is 1. And distance between 6 and 5 is 2. So what I was saying, doing this calculation is easy road, so I'm just not gonna do it. You do it, okay? The shortest, so when we compare two processes or projects, the one with the shortest average path length should perform better. So all of a sudden, now you have a way to compare two given processes, okay? With mathematics, quantitatively, not just qualitatively. So given a process, given a drawing, okay, so like a picture like this, you can compare two processes that are given to you with the average path length. Okay? And this is very powerful tool. So were you able to follow? Any questions? Irgendwelche Fragen? Ja. Laura, in die Prüfung, wenn es abgefragt wird, dann gibt es ein Graph, so ein Bild mit Knoten und Verbindungen und dann musst ihr das rechnen. Ich verstehe die Frage nicht ganz, muss ich sagen. Ja, das ist in der Regel so. Ja. Ihr bekommt ein Projekt oder einen Prozess, dann müsst ihr halt gegebenenfalls den Graph selber erstellen, aber das ist ja nicht, nicht schwer, so ein Bild zu machen und dann müsst ihr das selber rechnen. Ja. Die Frage ist, ob es in der Rechnung ein Verständnisproblem gibt oder ob es klar ist. Okay. Hat jemand noch Fragen? Okay, gut, dann mache ich weiter. Dem nächsten Clustering Coefficient. CC. Das ist ein bisschen anspruchsvoller. Das ist 1 geteilt durch n mal die Summe für alle Knoten von 2 mal L sub i. Ich erkläre gleich, was das ist. Geteilt durch K sub i mal K sub i minus 1. Wobei L sub i bedeutet die Anzahl Verbindungen zwischen den Nachbarn von Knote I, Anzahl Verbindungen zwischen den Nachbarn, okay, und K sub I bedeutet Anzahl Nachbarn von Knote I. Okay? Das ist die Definition von dem Clustering Coefficient. Und wie wir vorhin gesehen haben, je höher, desto besser. Lass uns das mit einem Beispiel machen, weil ansonsten ist es halt schwer, sich sowas vorzustellen. Nehmen wir den gleichen Graph wie vorhin. Ich male es nochmal, damit es immer vor Augen bleibt. 1, 2, ich glaube es waren 6 Dingen. So, I take 6 of this. 1, 2, 3, or 5 and 6. Oh, I just noticed that I put this in German. I'm sorry, I need to change it. second. So L sub B is the number of relationships between the neighbors of node E. Chi sub B is the number of neighbors of node E. Okay. So our example was, if I recall it, like this. Okay, so what is the clustering coefficient of this network? And then please now stay with me, because the first time you do this is a little bit difficult just to grasp it, but you will see that it's very easy if you hang in there. So it's just 1 divided by 6, okay, times. Now for node 1, okay, so I will paint it a little red one here. For node 1, the formula says 2 times L1, the number of relationships between the neighbors of node 1. Okay, what are the neighbors of node 1? 3 and 2, right? How many relationships do we have between the neighbors of node 1? Somebody tell me. 1. Okay, so 2 and 3 only have one relationship between each other. So L1 is 1. Okay, this is the number of relations between neighbors of node 1. This is L1. Divided by how many neighbors does node 1 have? 2 times 2 minus 1. So this is K1 number of neighbors of node 1. Okay? So let's do it for node 2. The equation is the same, 2 times. How many neighbors does node 2 have? 1 and 3. Okay? The number of relationships between them is 1. Divided by 2 neighbors times 2 minus 1. Okay? Next, let's do it for node 3. Node 3, I have 2 times I have 1, 2, 3, and 4 neighbors. Okay, what are the number of relationships between the neighbors? 1 and 2. Okay. One of the advantages of having the videos is that if you have any questions, you can go and see the video, not only the PDF. So the number of nodes of neighbors of node 3 are 4 times 4 minus 1 plus number 4 So the neighbors of number 4 are 1, 2, and 3, and the number of relationships between them are just 1. So this is 2 times 1 divided by 3 times 3 minus 1. Okay? Makes sense? For number 5, same music. 2 times 1 divided by 2 times 2 minus 1 plus for number 6 2 times 0 divided by nothing. I don't need to do it because it's just 0. Okay? It only has one neighbor, so this can also be done easily with your calculator. Okay? Is it understood? Any questions? Okay. Good. So the higher the clustering coefficient, the better the communication between the elements of the process or project. Okay? Any questions so far? Okay, I'm going to give you an exercise. Imagine you have a project with following work packages: 1, 2, 3, 4, 5, 6, and 7. Okay. You have a description. First is list the site. Second is arrange furnishing. Third is hire workers. Fourth is install furnishing. Fifth is arrange phones. Sixth is install phones. And seventh is moving to the office. We have the predecessors. The first has no predecessor. The second and third action have a predecessor of 1. This means that only when 1 is done can 2 start. Only when 1 is done can 3 start. The predecessor for number 4 is 3. Predecessor for number 5 is 1. Here predecessor are 4 and 5. And here predecessors 2, 6, and 4. And the duration of this is 1, 5, 1, 2, 1, 1, and 2. Okay. And the exercise for Laura, your question before, this is similar to what I asked in the exam. Okay. First, prepare the project plan. As Gantt diagram and as graph. And second, calculate average path length and clustering coefficient of the project. Okay? So please make sure you try this exercise. Today, tomorrow, we will continue with this. Okay, Laura, is the example clear? You asked before. So this is the way I am going to ask similar, okay, in the exam. Good. So anybody has any question? Okay, make sure you make this exercise until tomorrow, okay? Tomorrow we have another class, I think at 9:45. And I will build up on this, okay? Well, if there are no more questions, I can leave it here. I think it's enough.